With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is calculate T1 and T2. So here we have tensions as T1, T2. So if we draw FBD for this system, hence we can say here this mass M, here is suppose this mass M, and here we can say these are the three strings connected here. So here we can say this is our string of tension T1, this string is our tension T2, and this here is the string connected to this mass M. So the forces here, our forces as, let's say this is tension T1, this here is our tension T2, and this here is our tension T, which is connecting this, let's say, mass M. So here we can say the force on this mass M will be T upwards, and weight of this block mg will be along downward direction. So here we have this angle as 30 degree. So we can say here, if we draw, let's say, a line parallel to the wall, hence this angle here is our 30 degree, which implies this angle being alternate angle will also be 30 degree. In similar manner, we can say here, if we draw perpendicular from here to the base, so we have this angle as 90 degree, which implies this angle shall be equal to 60 degree. So this angle here is our 60 degree. Now here if we write equations for this mass M, so we have T as equal to mg. Next we can say here for this, let's say here we can resolve these forces. So these components of tension here will be our as T2 we can say of sine of 60 degree, and this component here will be our T1 of we have here as sine of 30 degree. Since the system here is in equilibrium, which implies here that T1 sine 30 degree must be equal to T2 we have here as sine of 60 degree. So sine 30 is 1 upon 2 and sine 60 here is root 3 upon 2. Hence we have the value of T1 as equal to, we can say here, as root 3 into T2. Next here we can, let's say, resolve these tension component along the vertical as cos. So this component of tension here comes out to be our T2 cos of 60 degree, and this component of tension comes out to be our T1 cos of 30 degree. Hence we can say here for this system here along vertical being in equilibrium, hence this comes out here as T1 cos 30 plus we have here as T2 cos of 60 degree is equal to tension in the downward direction. Now we have value of T1 as root 3 T2, so this comes here as root 3 T2 into cos 30 value we have here as root 3 upon 2, and cos 60 value we have here as 1 upon 2. Hence we have here tension as equal to mg. So we can say here this simplifies as our 3 upon 2 T2 plus we have here as 1 upon 2 T2 is equal to mg. So this implies that value of T2, this becomes 4 by 2, which is 2 T2 is equal to mg. Hence we have the value of tension T2 as equal to, we can say, as mg upon 2. Hence we can say here this tension T2 comes out to be our mg by 2. Now substituting this value T2 here, we obtain the value of T1 as root 3 mg divided by, we can say, as 2. So this is the tension T1 root 3 by 2 into mg. So these are the two corresponding tensions T1 and T2, which is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.